So you're really good at this, better than I am. What's 21? But even still, it's worth drawing a picture, I think, and labeling it. E, D, I, and W, U, F. So which of those statements is not true?
Yeah, it's 2.
Which one?
It has to be B.
Now look at B carefully. DIE is that angle, and
Oh no, you're right.
FU is that same angle.
I get it. No, it has to be D then.
Right. Angle D is not equal to angle W. Be careful with this. That's an easy mistake to make that you made there. And I think it was just you acted too quick. Okay? Just take a little bit more time. Maybe check out all 4 answers rather than just assuming because B didn't look quite right that it was the answer. Now, number 22 has to do with this. Hold on. We have linear ratios, we have area ratios, and we have volume ratios. Which one? They're asking for the volume ratio.
The answer is A.
Okay. So you're really good with all 3
because I know the square root of 4. I know the square root of 4 is 2, and the square root of 49 is 7, and 7 cubed is 343, and 2 cubed.
The real trick here is you go backwards first. In other words, even though they didn't ask for the linear ratio, we find it out because it's really easy to get
I have to go sharpen
from the linear ratio. It's the linear ratio cubed. So you're certainly correct.
I have to go sharpen my pencil really quick.
Okay.
Hey, I have to go sharpen my pencil. It broke.
Go ahead. I'll wait.
Okay. Thank you for waiting.
Now, notice one thing here, that we don't actually have to do 2 steps. We can get there in 1 step. In other words, we don't really have to go backwards to get forward. The relationship between the volume and
I know that, but
is 3/2, which is the same thing as taking the square root and then cubing it. So taking it to the 3/2 is the same process we did. The only thing is if you're doing that on a calculator, you can do that in 1 step instead of the 2 steps. We did it in 2 steps. We went there first, and then we went there. Okay? So you don't have to do it in 2 steps. You can go from area to volume, and you can go from volume to area. If you're going from volume to area, it's to the 2/3 instead of the 3/2. Not sure it's worth knowing that. It doesn't save you that much time, especially when they give you numbers that you can easily take square roots of and easily cube. It's just as easy doing the 2 steps manually as it would be doing the 1 step on a calculator. 23.
Yeah.
What is it?
Primary difference between two shapes that are similar but not congruent is their size.
Sure it's not their IQ? Being funny.
I have no clue. You know, really, I don't.
Trying to be.
It could be both, you know.
No, it's their size.
Yeah. I get that.
That is kind of funny. That he
Yeah.
put that on there. Because a lot of people would be analyzed by their size or their IQ.
On the test we took last Friday.
Yeah.
The answers were their angles, their shape, their shape, their size, their gender, and their orientation.
Oh, same thing. Well, it's nice to know that Jansik has a sense of humor.
I don't think he actually designed these, though.
All right, how do you solve?
Not these. His test, yes.
How do you solve this problem?
Yeah. Okay. So what I'm going to do first is I'm going to do 12x equals. I got to get a calculator out.
Well, notice that 5 times 50 is 250, right? 5 times 4 is 20. So all you have to do is add 250 to 20 in your head.
You get 270.
Uh-huh. In other words, some of these you don't
need
to calculate. You have enough math skills.
Because 5 times, no.
That you should
I get it.
do that.
Because 5 times 4 equals 20.
Uh-huh.
I get it. Because 5 times 4 equals 20. 5 times 50 equals 250. So add those two together and you get 270.
Exactly. Only when I do it in my head, I tend to go left to right. I do the 5 times the 50 first. Merely because that's the most important.
I don't care which I do first.
Well, it doesn't really matter, except if you're in the field and you're doing it, if you're going to make a mistake, you'd rather make it with the 5 times 4 than the 5 times 50. Because the 5 times 50 produces the tens digit, 5 times 4 produces the ones digit. You'd rather be off in the ones digit. In other words, if I was designing something in the field and I had to do this in my head, I'm going to do it left to right because I'd much rather get the first digit correct. 250 is the important one. The 250 is far more important than the 5 times 4, the 20. And it's a subtle point. But anyway, and then you divide both sides by 12 and you have your answer. Now, the next one's slightly different. What's that?
Yeah. I know that 20 times 17, x equals 4, 4x, equals 340. And I know that because I know that 20 squared equals 400. And 3 times 20 is 60. So subtract 60 from 400 and you get 340.
Okay, that's good. However, there is something fundamentally different about this one than the previous one. You don't actually benefit from cross-multiplying. In other words, because the x is in the numerator, all I really need to do is get rid of that 20. So if I multiply both sides by 20, it's only one step. Then I can cancel that with that, and I get 85 really easily with one step. So cross-multiplying is actually counterproductive. Notice what cross-multiplying is. Cross-multiplying is multiplying both sides by both denominators and then dividing. In other words, if I cross-multiply, I do this, but then I have to divide both sides by the number I just multiplied both sides by. So do you see where cross-multiplying is a little not the most efficient way to go?
Yep.
Get the same answer. But remember that if your variable is in the numerator, you don't need to cross-multiply. You just need to get rid of that 20. And then you're solving for x. And getting rid of that 20 was particularly easy in this case because 20 and 4 reduce. So I never had to deal with a number greater than 85. Whereas the way you did it, you had to deal with this big number 340. So it's a little better to not cross multiply on that one. How about this one?
So I know that 2 times 18, no, sorry, 2 times 9 equals 87, of course. No, it equals 18, and then 3 distributed among 2x minus 3 equals 6x minus 9. So I get 18 equals 6x minus 9. I added 9 to both sides, got 27 equals 6x divided by 6, x equals 4.5.
Notice how many steps that is. Now let's do it the same way I suggested we do the last one. My first step is not going to be cross multiplying. It's merely going to be multiply both sides by 9. And again, they make that nice and easy. So that becomes a 3, so that's equal to 6. And now the problem is at least one step quicker, because 2x equals 9, x equals 4.5. But again, do you see where cross multiplying is counterproductive? In other words, when I multiply both sides by this 3, I don't really need to do that. I'm trying to isolate that x right there. So the only thing I need to do is get rid of the 9, then I need to get rid of the 3, then I need to get rid of the 2. Okay? Now, this is a very subtle difference. This is not going to save you much time. But I like to see people always do algebra in the most efficient way. And if your variable is in the numerator only in these ratios, you do not need to cross multiply. This is a little different. This one, we've got the variable in the numerator and the denominator. So there's no easy way to do it. The easiest way to do it is to cross multiply. So what do you get?
You get, I got 7x minus 42 equals 8x plus 10. I added 42 to both sides. Got 7x equals 8x plus 52. Subtracted 8x and got negative x equals 52, or x equals negative 52.
Let's talk about this, because this is another subtle point. When we are on this step right here, we have to make a decision. We have to decide whether I'm going to bring my x's to the left and my numbers to the right, or vice versa. You chose to bring your numbers to the left and your x's to the right, and you ended up with all these negative signs. Okay? Notice that if I bring my variables to the left, I immediately get x equals minus 52. Excuse me, you would have ended up with minus x equals 52, and then you have to divide both sides by minus 1. So when you're doing these algebra problems, I'd like you to, when you get to that step, decide which side you're going to put your variables on, and that decision is based on which side is going to give you a positive coefficient in front of the variable. And clearly, if I move the 7x to the left, I get a positive coefficient in front of the x. That's my only consideration. Again, it's a very subtle point, much like cross-multiplying when you don't need to cross-multiply. But nonetheless, I point it out because you're really good in math, and I want you to always do these the most efficient way possible. What ratio can I set up on number 28?
That 9 over 12 equals m over 20.
Good. Pretty straightforward. And again.
And then I didn't do the cross.
Right. Again.
I did cross multiplication.
Multiply by 20. And then I get m equals 180 divided by 12, which is 15. And that's not the only ratio that's true. I could also say m is to 9 as 20 is to 12. Again, I don't need to cross multiply. I'm still going to get m as that. Remember, when you're dealing with these kind of triangles here, it's not only the ratio within triangles that's the same as the ratio within this triangle, but it's the ratio of corresponding parts to the ratio of the other corresponding parts. So either ratios are proper. Now, 29 is a little, well, tell me what ratios to write in 29 to solve for n first.
Okay. So it'd be 18 over 22.
Okay.
Equals O over 30.
Equals, okay, that solves for O.
O.
That's correct. And then again, I don't have to cross multiply. I just multiply both sides by 30 and simplify. And how about n? How do you solve for n?
Okay, give me a second. I still just show the work.
Put n in the numerator also, because that way you will save one step. If your variable's in the numerator, you will not have to cross multiply.
Okay. So my answer would be
Well, tell me the step.
18.
Okay, go ahead. Set it up. Set the ratio.
No.
That's the ratio
Wouldn't
is
it
the one I care about. I don't care about the answer. If you get the ratio, I know.
4 is to 6 as 8. 4 is to 6 is 18 is to n.
That ends up being correct. But it always makes me a little nervous because notice that you're comparing a trapezoid to a triangle. You see that? The bottom figure is a trapezoid. This is a triangle. Turns out that, yes, the ratio of those two sides is the same as the ratio of those two sides. But if we look at it as a similar triangle, then I would say n is to 18 as n plus 6 is to 18 plus 4. Do you see that? If I'm looking at the little triangle and the big triangle.
Well, that's more complicated.
Right, it is. Absolutely. And there's no question that the first ratio is the simpler way to do it. But to be honest with you, when I looked at this problem the very first time, I wasn't positive that n was to 18 as 6 is to 4, because I'd be comparing a triangle to a trapezoid. It happens to be true because this line is parallel to the base, but I don't know. I feel more comfortable looking at this and seeing two similar triangles. I see that similar triangle, and I see that similar triangle. And that one is 18, N and O, and this one is 22, N plus 6 and 30. And I know for sure that when I have similar triangles, n is to n plus 6 as 18 is to 22. And I can solve that. You're right. It does produce a more complicated expression. It's still going to produce the same answer. But I'm more comfortable doing it because I know I'm comparing similar triangles. I'm not comparing a triangle to a trapezoid. Now, that's the only page I had. Do you want to send me the first page? She and I only had a half-hour session, so it only took a half hour to cover this page. But you and I...
I'm sending the last page, actually.
Okay.
I already get the first 2 pages done anyway.
Okay. So there were 4 pages on this?
What? Yeah.
And this is the review material for your final?
Well, there were technically 2 sheets of paper.
Front and back?
This isn't it. We have 5 review packets.
And you've done...
I've already done 2. I have 3 more to do.
Just do page 3?
Yeah. No, we did, what we're doing is review packet 4.
Okay. Is this the review packet for your final, or you have a quiz this week? Your final's next.
Nope, final.
The final's next
We
week.
have a practice final tomorrow.
What's that?
What?
When is your semester final?
The finals, we have, okay. We have 5 non-multiple choice questions for the first part of our final this Friday.
Ah, okay.
And then on next Wednesday, we have 75 questions for a multiple choice part of the final, and that's Wednesday. The non-multiple choice final is worth 25 points. The multiple choice part is worth 75 points.
I had forgotten that Yancek likes to give his finals over 2 days. He's been doing that for a few years. I forgot. He's one of the few teachers that does that. Most all of my students have their final on 1 day only.
Well, most languages have multiple finals too.
Huh.
Like language, my German class is doing an oral final, like an actual test final, and just other things.
Uh-huh. All right. These 2 figures are similar.
Yeah. So, yeah.
Got a feeling this is not going to cause you any problem at all.
Yeah, no.
So what's the similarity ratio?
For...
Uh-huh. Well, if they're similar, the first thing we need is the similarity ratio, right?
Let's just do the similarity. Yeah, let's do the similarity puzzle for now. Okay.
So what's the...
So the similarity ratio. That's
little
weird.
to big.
Okay.
Little to big.
12 over. We're solving for y now. 12 over 20 equals 21 over y.
Okay, that's not what I asked. I asked what was the similarity ratio?
Like what do you mean?
What's the
For what?
Between this figure and this figure, how much smaller? What is the same side of this figure relative to the same side of this figure?
I didn't know you were. I thought you were talking about 30. I thought you were talking about 31, which is that angle puzzle like thing with the parallel line.
No, I'm talking about the top question.
Okay.
So the very first, we know that
similarity
the angles are all the same. In other words, B is
the similarity ratio. The similarity ratio is 3/5.
Okay. And that's the ratio we have to apply to every side. In other words, we're going to take 3/5 of 35 to get XW. And we're going to take 3/5 of 20 to get WV. And then we're going to take 5/3 of 21 to get BC.
Mm-hmm.
And as far as the angles go, I think you got that all worked out. What's angle S?
Angle S would be 150.
For that. They ask for angle A. What's angle A?
Angle A corresponds 161.
Okay, what's angle Y?
Angle Y is 112.
And what's angle D?
And then angle D 133.
Okay, now let's go back. BC is what measurement?
35 feet.
CD is what measurement?
C is 12.5.
I can't read what that measure is. That a 7 something?
Give me a second.
That's 7.5 or just 7?
7.5 divided by 3 equals 2.5. And then 2.5 times 5 is 12.5.
Okay, what's WV?
Where is WV? Okay. 20 divided by 12.
Okay, and WX?
Wait. 12 feet. WX. That would be 21, right?
Yeah. Notice that everything was dependent on that similarity ratio. That's why I wanted you to figure that out the very first thing. We know all the angles are equal.
That would.
But
Oh no, I would have known to figure that out.
What's that?
I would have known to have figured that out right away.
I know. All right, now let's go.
That's a big shape.
Let's go down and look at this one.
Okay, give me.
Now, we're going to run into a similar problem here as we have with that one problem. And apparently, you can compare triangles to trapezoids. As long as we know all these lines, these horizontal lines are parallel, and we do. So,
okay, I already have Y. My similarity ratio was 12 over 20, sorry, equals 21 over Y. And then I got 12Y equals 420 divided by 12 divided by 2, Y equals 35.
You lost me. You're going so fast I can't follow you. Give me the first thing you did.
I got 12 over 20 equals 21 over Y.
Okay, so 12.
And then I cross-multiplied and got 12Y equals 420.
Relative to the bigger triangle equals 21 over Y. Okay,
yes.
I like that. I know you can solve for that. Now, what's the next thing you can solve for? What's the ratio you're going to set up?
What ratio?
Let's solve for V. That's a little harder.
How?
It's a good question.
Yeah.
What did you get for Y?
35.
Okay, so we can say that V is to 21 as 20 is to Y. What'd you get for Y?
Which is 35.
35?
35. V.
And
Right.
you see, do you understand
Yeah.
the ratio? V is to 21. In other words, that side of that little triangle is the same as this
Yeah.
side.
4/7.
Ah,
4/7.
actually, is that true? I'm not sure that's true.
So 4/7 cross.
Let's do it a different way. I'm much more comfortable with saying 12 is to 21 as 20 is
V is 12. V is 12.
That's...
V equals 12. Wait.
I don't think so. All right.
What?
Let me think for a second.
Wait.
Definitely 12 is to 21 as 20, and that doesn't
84 divided by 7.
Yeah, that doesn't solve for anything. We already know why. So if we know why...
Yeah, no, V is 12. V is 12.
No, it sure doesn't look like it's 12. So what did you do? You said...
I know.
Get that.
So I did cross multiplication. So I got 21 times 4 equals 84.
Give me the ratio.
84
ratio, because cross
equals
multiplication
7B.
come from many different ratios. Give me the ratio you set up.
Well, I reduced 20/35 to 4/7.
Okay, so you said 12
That's
is
correct, right?
35 as V is to 21. Is that what you did?
No. I got 4 is to 7 as 20/35 equals 4/7.
All right. We don't need to. It's not 4/7, but the original ratio is what I want to
Yeah, it would be
make sure you can
20.
do.
No, 20 divided by 5 equals 4. 35 divided by 5 equals 7.
Where are you getting? Okay, so you're doing 20 is to 35 as V is to 21. Is that what you're doing?
Yes.
Is that true? I'm not sure that's true. In other words, is this ratio to this base the same as this ratio to that base? I don't think that's a true statement, to be honest with you. Hold on a second. Let's see. I can take that side. Let's see. I could say V is to 21 as V plus W is to 35, but that gives me two variables, and I can't solve for V. So that I don't want to do that.
Yeah.
If I'm looking at this as similar triangles,
Hey, I think I have a better idea. Wait, no, never mind.
What it is. Tell me what it is, because this is a little hard.
No.
To get V.
No, I was thinking, I was comparing trapezoid to a triangle.
Yeah.
It's not good at all.
We found out that you can actually get away with doing that. But, so what ratio did you get when you compared the trapezoid to the triangle? You got V.
28/35 equals 12/V.
Okay, now I get you. And those ratios are actually valid. You can do that. And only let's put V in the numerator because that'll save us a step. So that is 35/28. So we really have to go all the way down to this trapezoid to solve it. I don't know that we can solve it directly from that. But now notice that is all I have to do is multiply both sides by 12. And I get that. And then I can reduce it simple enough. That's 5/4. That's 3. V is actually 15, not 12. And 15 makes a lot more sense if you look at that picture. 12 didn't make sense. And let's go back. I'm curious as to whether how you got 12, I believe, by going v is to 12 as 35 is to 20.
Yeah, you told me that.
Yeah, and that's probably gives you the right answer also. Yeah, that does give.
No, sir, I got it to 21.
That's still
as
v equal 15.
I got v is to, I got v.
Hold on, let's see if I divide.
What I got with
by
v, what you told me to do.
3/5. I get 21 here. So that is not a correct ratio.
Yeah, no, what you told me was that v is to 21 as 20 is to 35.
And that's not true.
Yep.
In other words, notice that I'm comparing the wrong things. I'm comparing this side to its base with the other side to the base. Those ratios should not be the same. If you're going to compare ratios between similar triangles, then you have to compare the same side to the comparable side. That's the key. And I can't really do that with that top triangle and this second smallest triangle. But I can compare v is to 12 as this trapezoid, 35, is to 28. That is an allowable ratio, as we figured out with the previous problem. And so now that we got v is 15, what's w? Give me the ratio.
Okay. So that'd be 12 is to 20.
Hold on.
I'm writing this down. Equals 15 over 15 plus w.
All right. That's one way to do it. There's an easier way. Notice that I can use the trapezoid.
Oh, no, yeah, I'm getting you now.
Say v is to 12 as w is to 8, and I know v is 15, so now it's really easy to get w. In other words, once you've solved for v, then you should use the trapezoid relationship, which is generally quicker. Notice that when we use the trapezoid relationship, it saves us a step or two, as opposed to...
What do you get for w?
Well, 2/3 of 15, 10.
Okay. That's good.
Okay. And VWX is the only thing we haven't solved for, and we can solve for it the same way. Give me.
We haven't solved for z.
Okay, you're right. How do we get x?
It should be 28 is, or 35 is to 28 as x is to 20.
Yeah. All right. And now z, how do we get z?
Wait. Okay. How we find the z is we add up all of those numbers, is we get 20 over 68 equals 35 over z.
What was your ratio again?
20 over 68, because I don't want to have to do that one below it in between.
Okay. So the side is to the total side.
Yep. As 35 is to z.
You're doing the other side now. We've seen that's a mistake.
What I was doing is 30.
You did this side is to z. Here, let me give you a really easy way. this side of the largest triangle you see is 68, right?
Mm-hmm.
That is to Z, as there are similar triangles. Let's just do 12 to 21. You see that?
Mm-hmm.
That's the simplest way to do it. In other words, make sure you put your ratio the same. We're doing the left side of the triangle divided by the base equals the left side of this smallest triangle divided by the base. And now we only have one variable. We can calculate Z quite easily. All right.
Okay.
Hold on a second. Interesting.
Why wouldn't the 20 over 68 equal 6 over 7? Because the 20, which is the smaller triangle,
How did you get?
over 68 of the larger triangle equals 35 of the smaller triangle over Z.
Where are you getting? Oh, you're getting 30. Where are you getting 35 from?
Why?
Y was 35?
We already found Y, so now we can...
Okay, and
Yes.
Y ended up being 35. I'm not writing down these answers, so I didn't remember what Y was. But I did it slightly.
No, it's fine.
I did it slightly different. I did the left side of the big triangle is to the base of the big triangle, as the left side of the little triangle is to the base of the little triangle. So I had 68 is to Z as 12 is to 21. That's the simplest math, I believe. Like I said, there's 5 different ways you can put together these ratios. So there's not just one correct method.
Yep. What do you get for Z, though?
I didn't calculate it. I don't care what the answer is. You know, once you set it up, the ratio, that's the only thing that matters. I have confidence that you know how to do arithmetic. Arithmetic,
Yeah.
different than setting up the proper ratio. It's easy to set up the wrong ratio if you don't see the problem correctly. Once you set up the right ratio, then you're going to get the correct answer for C. I don't care what the number is. All right, 32.
Okay. I'm getting the ratio 6 over 10 equals X over 72.
Okay.
Height to shadow.
Yeah, that sounds right. I would prefer to draw a figure. If my life depended on it, I'd want to do it this way. He's standing at the bottom of a cliff, which is casting a 72-foot shadow. So there's our picture. If Eddie's shadow is 10 feet, which I guess has to be this number, so 6 is to 10 as X is to 72. Is that what you said?
Yep.
Okay. Again, that's all I care about. I don't care about the exact number for X. 33.
I got X equals 43.2 feet.
Okay.
Yeah, it doesn't matter. Okay. Give me a second. I'm going to get my graphing calculator out.
Again,
thank you for teaching that.
Let's make sure we get
thank
the
you so much
set up. I don't care about these answers.
Oh no, I know how to get the ratio set up, but thank you so much for teaching me how to do that.
Oh, by using fractional exponents?
Yeah, no, 686 divided by 1936. Oh, no, 686 divided by 2,662. To
that's
the power of 1/3.
okay. Good. What do you get when you take that to the 1/3?
Give me a second. 3. I get 7/11.
Okay, and that is what ratio? Is that the linear ratio or the area ratio or the volume ratio?
That's the linear ratio. Linear ratio.
So they're asking about surface area.
And so then I can
What's
square.
the surface area?
Square and get. Give me a second.
Okay.
Yeah. The surface area ratio equals 49/121.
Okay. And they're giving us the surface area of the bigger.
Volume.
Well, we already used the volume.
And then 11 is cubed is 1331, right?
Didn't hear.
I'd like to have, yeah, I'm correct.
The whole key.
I want to have all my.
The whole key we've solved for, the area ratio. And they're giving us the surface area of the bigger object. So where does that go? In the numerator or the denominator?
It goes in the denominator.
So that's 1936 pi. That's what we're trying to figure out is x.
In my ratios, I don't use the pi because I'm just gonna have pi in the other one.
Well, except okay, but that's fine as long as you include the pi, whatever you get for x. It's a little dangerous doing it that way. In other words, if I don't write pi in there, I'm liable to write x as the result of this ratio, and that's not the correct answer.
Well, I remember to use correct units.
Well, I'm just saying it's safer to put pi down there. You didn't need the pi to come up with the linear ratio because we knew it was pi divided by pi. So this 7/11ths was going to be 7/11ths whether I used pi or not. But then I got the area ratio, 49/121, and I got to figure out what the surface area of the smaller cylinder is. I better use pi because the surface area of the smaller cylinder is going to have a pi in it. I don't have to convert pi to a decimal. In other words, here's the answer. Divided by 121. So I'm quite confident that 49 times that number divided by 121 is going to be a number, and then we're going to follow it with pi.
49 times 1936 equals 94864, and divided by 120, or 121 equals 784. So the surface area of the smaller cylinder equals 784 pi centimeters squared.
Okay, good.
Wait, that's really weird though, because
that problem?
that's super weird because the surface area shouldn't be bigger than the volume.
What'd you get for this number? 784 pi?
Yeah.
You bring up a good point. So we did our math wrong.
Or no.
Let's see.
No, we didn't.
Volume ratio
we got
is 686 to 2662.
We got the correct ratio.
We take the cube root of that to get 7/11. That's the linear ratio. We square that to get the area ratio, which is 49/121. That has to
and then I use that.
The small to the surface area of the big.
Yeah.
Must have done your math wrong.
I can.
It should be about 1/3. Should be about 1/3 of 1900. 784 is not correct.
No, it is. It is correct.
Really?
Yeah.
Yeah, you're right. It is correct. 784 pi.
We did our math correct. Maybe Yansak's dimensions, or not Yansak's, but this company's directions were faulty. Sorry, dimensions were faulty.
Yeah. It is a little peculiar that the surface area would have a bigger number than the volume. Even though it's centimeters squared and the volume is centimeters cubed, it's rare that the area is bigger than the volume unless it's less than 1. Then it could be true.
Yeah, you're right.
What's going on here? Let's see.
Unless the volume is 1 cube, is 1.
Did you do the cube?
Is 1 cube. Is 1 cubed centimeter, in which the surface area would be more.
Right. No, you're right. So it's not impossible for the surface area to be bigger than the volume. But it is a little strange. But apparently that's the case here. Actually, the problem says determine the height of the larger cylinder and the surface area. So let's go back and find the h. What's h?
Well, okay, it's 33 centimeters.
Okay, that's 11/7 times 21.
Yeah. How I know that is because 21 divided by 7 equals 3, and 3 times 11 equals 33.
Right. Okay, so you got h correct. Well, I don't see any mistakes we made in calculating surface area, so I guess we'll go with that 784 pi, even though it is a little strange. Especially since the surface area of the big is smaller than the volume of the big.
Yep.
Well, let's not worry about it at the moment. All right, it's 5 o'clock. I'm going to let you go. Bolton, we'll have one more session before your second part of your final, I guess, next Tuesday. I'll talk to you then.
Yeah. Well, the second part of the final is just going to be vocabulary and stuff, which is really, really, really easy.
Okay. Meaning what? You're not sure you're going to need a session next Tuesday?
Of course I'm going to have the session. It's just I'm saying maybe plan for more on the vocabulary side.
Okay. All right.
Like vocabulary and using vocabulary.
Right. I'll do the best I can. That's not.
I'll be done with all these reviews by then.
All right. I will talk to you next Tuesday at 4.
Okay.
All right.
Bye.